Welcome everyone this afternoon to the Hudson Institute's panel on advanced batteries and America's national security. I'm really looking forward to our conversation this afternoon. We have four really interesting experts representing different parts of this issue. I'll begin with brief introductions, and then I'll go into three general topic areas that I'd like to cover today, but most of the talking will be by our panelists and not by me. So I'm Nadia Schadlow. I'm a senior fellow at the Hudson Institute. I'm co-chairing a project called the Hamilton Commission, which is focused on critical areas of America's supply chain. We have with us today Mr. Ben Richardson. He's the Director of Advanced Energy and Materials at the Defense Innovation Unit. He's in charge of delivering strategic energy and materials capabilities to the military by accelerating the adoption of commercial technology into the DoD. Tough job. The portfolio is focused on three primary lines of effort: advanced power and energy storage, next generation fuels and mobility, and materials and sustainment. And also from DIU, we have today Dr. Nina French. She is the technical director of the Advanced Energy and Materials portfolio. She's responsible for technical due diligence and assessments of the commercial technology that the portfolio is considering. She's also a special advisor to the director of DIU and responsible for DIU's academic and laboratory relationships. Mr. Jim Caley is the director for operational energy for the Navy. He's serving as the Secretary of the Navy's focal point for all matters pertaining to operational energy. And before this assignment, he was the director of the Marine Corps Expeditionary Energy Office. And last but not least, we have Dr. Kyle Grew. He's the chief of the Battery Sciences Branch at the U.S. Army Combat Capabilities Development Command, DEVCOM, which is a part of a subordinate command of the U.S. Army Futures Command, for those of you following these things. Kyle is responsible for developing the strategy for and the execution of the Army Research Laboratory's basic and early applied research into battery technologies. So as you can see, we have a range of experts on the panel, and I'm looking forward to getting into some of the key issues. I'd like to structure the discussion first, talking a little bit about what is operational energy and what are the kinds of challenges that DoD sees that batteries can help solve in this domain. I'd also like to talk about DoD initiatives in this area, and all of you are focused on different parts of this, so I think that will be interesting. We'd like to talk also about some of the opportunities as well as constraints and obstacles in really making progress in this domain. And finally, I hope to get into some future-oriented issues. Where are you thinking about future technologies, and how should we think about this space going forward? So why don't we start a little bit. I'll just throw out randomly, Jim, because you headed before the Marine Corps' Operational Energy Office and are now working with the Navy on these issues. What is operational energy for the audience in terms of advanced batteries, and how are we thinking about that domain and the kinds of challenges DoD can help to solve?
Operational energy has a legal definition, and it ties directly to the energy required for training and operating your forces, in your mission environment. And advanced batteries, frankly, they are essential for the future, the way that the Navy and the Marine Corps expect to operate going forward, because advanced batteries enable things like electrification and hybridization of the battlefield, allow for sharing of power between systems, and allow us to extend the operational reach of our key weapons platforms, such as ships and vehicle systems, combat weapon systems and airplanes. And going forward, if we're going to fight in a distributed environment and be prepared to meet our near peer competitors successfully, we need the capabilities that advanced batteries bring to enable things like unmanned aerial vehicles, unmanned underwater vehicles, to give us long dwell, long duration surveillance and reconnaissance capability that frankly doesn't require us to lift fuel that costs 6.9 pounds a gallon, and frankly enable us to do things where we can operate from greater distances or at greater ranges and that we can leave weapon systems on station for a longer period of time. So I think that's a good introduction.
Would anyone like to add anything to that? Kyle?
Certainly, what Jim alluded to certainly resonates with me and what I see from the Army perspective as well, in terms of interests and looking at things like electrification, extending the reach of our systems and our platforms, the proliferation of capabilities like autonomous systems. And then additionally, from our perspective, certainly, if we look at the individual warfighter, the capabilities that they need down at the soldier and squad level with some of the equipment and accessories and communication devices that they're taking with them. I think the other thing that I would add, which really complements what Jim alluded to, is that storage of our energy in advanced batteries, in addition to extending our operational reach, it is also very accessible. It is direct to use. We're not worried about how we're going to convert it and any transients or time in getting operationally ready. And so that would be what I would add. Thank you.
So some of the challenges that we're seeing vis-a-vis China, other adversaries and competitors that are fundamentally making it hard for us to sustain operations over long distances.
Well, so there's more capabilities here, right? So one of the things that we haven't brought up is that, like, those advanced batteries enable things like silent watch. We can turn off our generators and turn off our trucks and operate much more quietly. You know, if we have an electric outboard engine powered by a battery, we can go in at speed with that engine not making noise. And so these technologies provide alternative benefits to the warfighter that are frankly hard to quantify, but superb in terms of, retired Marine like I am, anything like that where I can give more than one capability for the same dollar, I think is good value to the warfighter, but more importantly, it's good value to the American taxpayer.
I can add two other quick points on when you think about global integrated operations, and we think about operational energy is deployed, but there's a lot of connected tissue to the bases, either continentally United States or bases overseas, and you look at resiliency on those bases and the need for them to be supporting our forwardly deployed forces. So batteries also come into play when you're looking at resiliency on bases also. And then from a market perspective, as a second point here, some of these concerns that we have about advanced batteries are the same things that we're seeing with regard to cities and towns that need resiliency in the commercial market space, right? Where, you have rolling blackouts in Northern California every year because of fires. Towns want to have, batteries, advanced batteries for them to remain resilient and create options for them. And even down to individual homes, right? You want options there so you're not subject to the rolling blackouts that are occurring at certain times of year around the country. So that helps spur the market, the commercial market there, which helps DIU bring some interesting technologies into the operational energy space.
Nina, did you want to add to some of those discussions?
I want to add to what Jim Caley said, is that this idea of silent watch, I think, is really important. I mean, there's fuel savings on top of that, which is important. Many of these vehicles sit idle for 80% of the time on idle, but we still need climate control and energy for the vehicles. So DIU's just started a project where we're working with the Army to use their battery and do a parallel vehicle electrification. But I think Jim is right that the vision really needs to be, how do we take these tactical vehicles and bring them into full electrification? You gain a lot when you start from scratch. So doing what we're doing now for the Army is a little tiny bite of the apple, but I think Jim is right. What we want is a fully electrical tactical vehicle across all the services. And I think that requires us, I mean, there's so much commercial available technology, but it requires us to kind of think from the beginning and then bring all the benefits from a fully electrical vehicle. Jim, is that what you were thinking? You want to dialogue with me on that?
Yeah, so absolutely, Dr. French. So I will say that, like, we have experiencing baseline designing something. So, the Group 2 UAVs, the low altitude unmanned aerial vehicles that the Navy and the Marine Corps use, have about 90 minutes and 4 hours of duration. And you can do some cool things with fuel technology to get it about 12 hours. But if you redesign it and start from nothing and integrate technologies in ways that, frankly, all the scientists and engineers know how to do it,
Right.
we have a UAV that stays in the air for 4 hours. I'm not sorry, not 4 hours, 4 days, right?
Oh, wow.
So when you start doing things like this and rethinking of how we traditionally think of these systems, you can turn them into much better, frankly, combat enablers, right?
Exactly.
So one of the
Right.
vehicles that we idle forever in the field is a vehicle that moves something called the network on the move. And you never turn the vehicle off if you want command and control to work. All you have to do is add an advanced battery, and you can work for significant numbers of hours a day without running fuel. So yes, absolutely, Dr. French, right on the money.
But again, if you take that concept and you think, where do we want to be 5 years from now? We don't want to just add a battery to it. What we want to do is rethink the whole thing. And we want to think about something beyond lithium ion. 5 to 10 years. Lithium ion is with us to stay, and I'm sure of that. But as I know Jim knows, that we've got safety issues, and that concerns me on the battlefield. So where do we go into alternatives to lithium ion? Where are we going to be 10 years from now? And then we always think about designing really from scratch, if we can, taking commercial technologies, which is what DIU does, but thinking about what are the requirements for this vehicle that idles forever, and thinking about how we can design it from scratch. And I think that Ben has brought up some good points. We also have to think about how to recharge these batteries.
Right.
And so, do we go in, do we have a drop station where we drop the batteries? Do we have 7 batteries? Do we have 2 batteries? Do we replace them? There's infrastructure on the battlefield that is different than at a base.
So could we talk about that a little bit? I would be interested in understanding more about how DoD is thinking about the recharging problem set. And also, to go back to Nina's point, is there cooperation across the services in terms of thinking about this space, right? Are requirements being developed in such a way that they're so specific that it really is going to make it hard to scale to produce the kinds of batteries that are necessary? Because as part of this conversation, I want to get to that problem set of who can produce these batteries, right? Some of the supply chain issues. So first, is there decent cooperation across the services? Is it still in that dream state, or where are we in that?
So I'll start with this, because we actually, the Navy is kind of the center of all the safety standards around these things. And we know all the lead engineers in all of the services, all the lead scientists. And for example, we follow the Army's lead for vehicle batteries, and we go in their direction, and we make sure that we are working with the Army to develop safety certifications for critical vehicle batteries. And I would say that from my perspective, we cannot afford, as a Defense Department or even as a service, I can't afford the economies of scale necessary to produce discrete batteries for every one of my weapon systems that are going to be different from the Armies or the Air Forces. And so in truth, we're all in this together. Otherwise, the taxpayer is going to pay a huge bill, because these batteries for us are expensive to get right.
If I might add on that.
Oh, sorry, go on.
I think, if I could expand upon that. I certainly agree with Jim's comments there. I know, for example, the researchers on the Army side are very engaged with the Navy and the other services through a lot of the safety programs like BDSX and several of these that are really at the technology level and focused on getting key aspects of them right. I think the other thing that I would note is that when we look at how we operate, really, if we're in an engagement, it's a joint force. And so if we think about how we're going to potentially deploy, even as an Army institution, certainly equipment and stuff is going to be getting there on Navy ships and an Air Force aircraft. And so we have to be on the same page in terms of what we're doing from the technology standpoint.
The other side of this is that in order for us to get the economies of scale that industry can get, frankly, we've got to be able to accept some of the industry standard batteries into our weapon systems, even though right now, for example, electrical vehicle batteries are relatively unsafe for me to put on board an amphibious platform and risk a confined space fire. But for that organization, the Battery Development Safety Enterprise, BDSX, literally works on coordinating all the different mitigation research and development so that potentially we can build a battery box that could contain an industry battery on board a weapon system without risking that a fire might destroy the inside of that ship or even worse. And so we look not only at working together with each other, but trying to find a way to get the economies of scale that, for example, the auto industry gets when they're building electric cars. So we really want to develop technology that also enables industry at the same time.
And I think,
go ahead, Nina.
I just think Jim is right there, just to pick up on that especially for the Navy, seeing what you are doing in containment, containing individual batteries. So if one battery blows up, it doesn't blow up everything. I think that's important. I think sensing is important, and real-time testing. And I think those three technologies will help us bring commercial technology into the DoD. Go ahead, Ben.
Yeah, I was just going to add, we're not fully standardized inside the military, but there's good conversations going across the services. But industry is not fully standardized either, which is the other challenge on this, right? But what Jim was bringing up, and you furthered those points, and keeping flexibility in how we operate. So if we build, our capabilities around things that are flexible, as containment, other things that can happen there, then we have more options with those batteries that we're getting from industry. As we continue to see new prototypes. And it's one of the challenges with DIU, looking at where the industry is at right now, is that there's so many different prototypes out there in the marketplace, so many different good options for lithium ion and other chemistries and where they will go. How do we make sure we're tapping into that and looking for the best option? Because it's not necessarily looking for the one right battery, it's the right battery for the right mission. But now you're looking for fast recharging, longer endurance, other things that are required there. So it's important for us to keep an eye on the commercial market, but also keeping flexibility in the way we design our systems and how we evaluate them.
At the same time, Ben, it's important that everybody understand, particularly our industry partners, understand that industry standards, frankly, may not be good enough. Allow me to point out, how many times have you been into other places in the world where it's always above 120 degrees in the sun? And you leave your phone on the car of your seat, it turns black and won't operate. And the lithium battery that we want to hand to our Marines and our soldiers and our airmen needs to function in the heat or function in the cold. And some of our weapon systems require some batteries that are, frankly, extremely capable and way more capable in terms of speed of power output than what industry might need, particularly to support things like directed energy capability and electronic warfare capability. And so I would say, yes, in things like vehicles, we need to go with industry to the greatest extent possible. But we also need to understand that industry needs to be prepared to meet some of the advanced requirements for us that extreme environments bring to the battlefield.
Well,
totally agree there.
Could I ask just if there is then room, it strikes me as, is there such a thing as a standard setting body equivalent, right? We use that term internationally when we're talking about US, China, and other tech areas. Yeah. Is there an internal US standard setting body or conversation that's taking place to address some of these issues? Is that what the Federal Consortium on Advanced Batteries does, or is there an opportunity there?
So there is an opportunity there with the Federal Consortium on Advanced Batteries, but more importantly, internal to the Defense Department, we have something called military performance standards. And so for every battery that we have, and for example, a vehicle battery like a lithium ion 6T, the Army is the lead on that MilPerf or military performance specification. And what we try to do is communicate adequately to industry what the requirements are. And we're not very good at this in the lithium battery space, but we're working really hard to get to this point where we're producing better specs to be able to communicate with industry. The other piece that we really need to help industry with, though, is to bring them into the safety standards and the safety certification process. So, I'll give you a counterexample. The Navy and the Marine Corps, all the services buy munitions. Munitions explode, they burst on fire, they make bullets go boom, missiles fly. It's super expensive. It's super expensive and it's super dangerous to put in confined spaces. And there are really big safety concerns around this stuff. And industry produces all of this stuff for us, and they're part of the inspection process, and the Army and the other services go in there and do quality control, but safety certification is done in their facilities. So we want to get to a point where we can do our safety certification in partnership with industry going forward, so that we can enable them to be able to be successful in our space, as opposed to having discrete knowledge about the dangers that we're dealing with.
Thanks, Jim. Did anyone want to comment on?
I'd like to just kind of have a dialogue with Jim for a minute. So you're talking about kind of an integrated systems approach here. You're talking about saying, I know how my missile blows up, I know how my ammunition blows up, but let me put it in a confined space and figure out how they interact. Is that what you're saying?
No, so if you look at munitions, right? So munitions in a particular way, let's just call artillery rounds for right now. So powders perform in a particular way, and if they don't perform in a particular way to launch that artillery shell, then it's a big problem because people get killed on the battlefield or the round fires in some wonky direction. In the battery safety world, and we have a way to inspect industry so that industry successfully delivers these highly dangerous items to us every day, all the time, and they're really good at it. And we have a way to inspect that process. And in the advanced battery space, that's what we need to do. We need to bring in industry as partners on the safety requirements and the safety certification piece, so that industry knows how to get it right, and we can just QA their procedures like we do for many dangerous things.
That makes a lot of sense. But I was thinking that you were kind of looking at the integrated systems approach and saying, in these situations, I've got a battery that has all these other explosive elements next to it. Am I going to do certification so that if this happens, the battery doesn't explode? Is that kind of what you're thinking?
So yes, but part of that is on the Navy. When I say part of that is on the Navy is developing containment systems so that if we want to put a battery, let's just take an example, a battery on a medium tactical vehicle, right? So something that Kyle super familiar with. If I want to put a battery on a medium tactical vehicle and it has to go into a well deck on a ship, then I need the battery, if it fails, to have an amount of time for the fire system on board the ship to react, which means that the box that the battery is in has to be able to contain that heat discharge for a particular period of time. And I want to provide that to industry in that process, so that if one of the folks like Oshkosh, which produces many of the Marine Corps vehicles, are producing trucks for us, that we have a way to get them to, yes, you can use this advanced battery to help us.
Okay. I'd like to go back to the recharging issue as well. So I think before I'd like to get to some of the strategic issues. Recharging, also a discussion of energy density, because that had been also a criticism of some of the discussions at Hudson. My co-author Arthur Herman and I put out an article in the Wall Street Journal on DoD operational energy and batteries, and some of the letters to the editor were critical and actually mentioned the 2 points: the problem of recharging and the problem of energy density. And then I'd also like to look at some of the supply chain issues. So even if we get to this wish list of what DoD wants and needs, who produces them? And how quickly can that be done? And what are your views on overall supply chain issues? So on recharging, how does it fit into this equation? Kyle, I see you nodding a bit, so go ahead, please.
I think, and especially from the Army perspective, this is a really important issue. As we start to look at electrification, whether that is full electrification or hybridization, especially when we're talking our platforms and you're in a deployed scenario, how are you going to get the amounts of energy that would be necessary for those platforms on them in a forward location? And so I think that is one of the challenges and one of the questions that we still need to answer on whether that is the right thing to do, whether that is practical, and what the impact is. There is a lot of enabling capability from going electric or hybrid electric, things like the silent watch that were mentioned before, but we also need to make sure that we are doing it correctly. And a piece of that, and I'm just going to tie to the point you brought up about the energy density. The energy that is stored in these batteries is one of the key aspects of it. When you look at tactical vehicles and the size and weight, the scaling is not necessarily the same as what we see in the commercial sector with vehicles, all the electric cars that we see that are on the road right now. And so what the actual capability is there in terms of endurance, range, things like this is very important. And that is one of the reasons why it is so difficult to break that chain to things like fuels, is because there is a tremendous amount of energy in a gallon of gasoline or JP8, much more than is in our current battery systems in a compact form. Now, those systems that convert that, our internal combustion engines and other things are not nearly as efficient. We've got those conversion steps. There's a whole lot of other things that we've got to deal with in those. But this is an outstanding issue and question that we need to address both from an Army perspective and a Department of Defense perspective.
And is DIU addressing some of these issues, I imagine, in some of the new technologies you're looking at, Ben and Nina?
Yeah, I mean, we're definitely looking at where the market in the commercial space is happening here, but we do have to rely on, where the Army and the services want to go from the requirements, right? So our role at this stage, because it's really about the infrastructure of the battlefield, is informing the Army on what's happening in the commercial space and the options there. There are similar issues, but they're different, right? There's similarities, but the differences in this, battery infrastructure, recharging infrastructure has been a huge hindrance to the growth of the EV market inside the United States. But obviously we've seen the growth of that, but there's a big difference in the conversation between where we've seen the biggest growth of EVs in the United States, which has been around the commuter cars, right? That was the original, tagline of this, the 40-mile commute. And so you can charge at home, or you have certain charging stations in certain locations. That's a relatively straightforward issue there. We saw for a bit there was, and there still was some technologies on there about swapping out batteries. You drive up, and I think Tesla a number of years ago had the comparison how long it takes you to, fill up your gas tank versus roll up your vehicle and switch out the battery. But there are similar issues in the options for where we take this. Are we simply bringing these vehicles back to a point on the battlefield where we're recharging them, and then if that's the case, well, what are the options for rapid recharging? And obviously, in the commercial space, you want rapid recharging, but on the battlefield, that will be even more important. You have the swapping out the batteries, like, whether or not that's driving up to a platform and removing them and putting them back in, or physically taking them out. And that gets into issues about where the batteries are, because there are options to, some of the platforms that we've seen, such as UAVs and other things, where you've put batteries all over this platform, every space that you can. So there's not just one battery, there's lots of them. So removing and putting batteries back in becomes kind of challenging there. So there's lots of options. I think there are similarities in the challenges that the commercial market has, that the military has in an operational environment. But obviously there's more options to how the commercial market can solve that, because those challenges are a little bit different. Ultimately, I would expect the rapid recharging issue to be, one of the areas that we really like to see that move forward. And obviously, there's a lot of investment in the private sector, because nobody wants to be sitting around for 30 minutes or an hour, on a cross country trip waiting for the car to recharge. They want to be able to drive up and do a rapid recharge and keep going. It's the same thing the military wants. But there's other parts of that infrastructure in the commercial market space that's tied into something where you have a rapid recharging space, and it's tied into infrastructure. On the battlefield, rapid recharging, well, am I still gonna have to move in some other vehicle or some other large infrastructure where the batteries are? And what does that look like? How do I tap into that? Am I tapping into a local country's grid? Is that reliable? Is it not? How does that look? So that piece of it is where we have to kind of rely on the Army for, what is their risk tolerance? What do they need? What do they don't need on the battlefield? And then we can, bring forward the commercial options that are out there. Hopefully that makes sense, Kyle, for where you're sitting on the Army side.
No,
So-
I think you put that very eloquently, Ben. I appreciate the perspective, and I agree with you wholeheartedly on some of the similarities and differences.
So I
Nina,
will say from the perspective of the Navy and the Marine Corps in this space, we need common sense solutions now. The hybridization advantages are available in technology today that will basically, and this is a generalization, but it will allow our vehicles and frankly our ships to go about a 25% further on the same fuel. And so while people can criticize the full electrification piece, which there are a lot of concerns that I have in that space in terms of practical solutions that work inside of a targeting cycle that might be a few minutes, and something that might limit Marines' mobility, which would be super dangerous and bad. So I'm not totally there on the full electrification necessarily of an asset like that, but hybridization technology is here now. And none of the assets that we currently use on a broad basis, we've done some experiments and some prototypes, but none of the assets we use on a broad basis, except some of our ships, are hybridized. And so we already know this is a 25% reduction in fuel. That's a big deal. In terms of the Navy's fuel budget, if I were to hybridize 100% of the stuff in the Navy's stuff, that's 25% of an average of $3.8 billion a year. That's a big amount of money. Now, it's expensive to hybridize things, but I just wanted to go back and go full electrification. Yeah, I don't know. But from a common sense perspective and where industry's already taken us, taking some of the industry tech and putting it into our vehicles to hybridize our trucks and combat systems and ships and make them go further, we know it works.
So Nina, do you want to comment a little bit about that?
I do, and we have a solicitation out right now, Jim. I'm sure you know that for this parallel hybridization of JLTVs. And it was really interesting to look at the industry, the commercial feedback, because yes, you're right. They've been doing this for cement trucks, for garbage trucks, things that sit at idle for a long time. And their fuel savings is significant. I don't know that it's 25%, maybe we can get there. But now we'll get the devil in the details of, is it a pack of 10 batteries or, 3 batteries? And can we evolve into something? I agree. I like the idea of hybridization. My son is a car guy. He's 24 and he just bought a Tesla and just did a LA to Portland trip and was kind of bragging about the gas savings. So I kind of got this firsthand in a very personal way. How often did you have to stop and how long did it take? And the Tesla actually tells you this is the optimum time to recharge because you get a bigger bang for the buck when you recharge early. So I think that we're going to learn a lot from industry, Jim. But I do also think that talking to some commercial vendors, that some of these vehicles could be better designed to be all electric without jeopardizing safety and creating a standard that that makes reliability work. And that's maybe a 5-year vision, 7-year vision, I don't know. But I think this hybridization is going to be very interesting to watch and to actually put a metric on the fuel savings. We will monitor that and to take this commercial technology and deploy it in our vehicles and in our ships.
Ben?
I just hit a couple points there. I mean, like Jim, fellow Marine, I've been out in those situations where, the optimal time to recharge or something may not always comply with what the enemy wants to identify as the optimal time to stop the fight. Right. But there is a point there though regarding like the commercial technology around battery management, right? I mean, knowing where, giving more information to those units, not only the forwardly deployed units, but the command centers, right, looking at their vehicles and looking at other things they're using batteries on the field to understand where they are and And we need to get into concepts where reinforcements may be needed in certain places because battery charging is going down, or we need to move other forces forward because of where the optimization for recharging and other things. Those are concepts that are years out, but things we need to start thinking about. And battery management is an element of this. I think of this in phases, and I don't mean it in the sense that we have to go down past, because I agree with you, Jim. There's a lot of unknowns with full EV at this stage. We fully get there, and it has to do with infrastructure and how we'll operate. But the conversion, the easy one is the conversion of existing vehicles and getting that 15, 20, 25% gain in distance and fuel savings. That is very important from a financial perspective and also a capability perspective. But then there's like designing vehicles that are hybrid from the design up. And obviously you're going to get more out of a vehicle from a capability standpoint if it's designed to be hybrid versus converting something that wasn't originally designed to be that way. But obviously we should do some conversions, which is where DIU is looking at, that Nina mentioned right now, because we have so many vehicles out there in different types that can take advantage of this. But then that third potential phase down the road is the fully designed EV, and you get silent watch, you get signature on the battlefield, you get more capability from a distance, fuel savings, and then the ultimate goal is where we're going to be with directed energy weapons and electronic, these things that are going to be added onto vehicles as capability demand for future vehicles or current ones, and just the power requirements that are going to be needed. And that's where you really get into those requirement pieces, where DIU can provide to the requirement folks, hey, this is what's happening in the commercial space, but we're still going to defer to the requirements folks on what's really needed and how the battlefield's going to look like.
So I'd like to go from what sort of the present to some of the future for the second half of the discussion, because we're almost halfway through. So part of this is, again, can DoD achieve some of these goals in terms of where the supply chain is today? What does DoD need to produce? What does the United States need to produce for the Defense Department? What are the obstacles in this domain? And then I'd also like to make sure that we also get to the most promising future technologies beyond lithium ion as well. So in terms of supply chain issues, before we started the discussion formally, Nina had mentioned recycling. That's one part of the supply chain. There's a cell production. There's the manufacturing equipment to even manufacture batteries that we don't even, we have serious limitations in as a country. So I'll throw it out there. We'll sort of maybe go.
Let me back up, because in my mind, supply chain starts with mining.
The minerals, right.
And then not only mining, because now there are places where we mine it and we send it to China to refine it.
Right, the whole thing.
Yeah, so it's mining, it's refining, production, and then you build a cell, and then you put the cell into a battery. So it really starts at the very beginning. I think FCAB has a team that is looking at that. We had a Cambridge project under DIU that looked at it, came up with some policy guidelines or thoughts. This was 4 students from Harvard, MIT, all Boston area schools. And, they put a lot of thought into it. And, we have serious supply chain issues. I think FCAB is a really good source for that. Kyle or Jim, do you have any thoughts on that?
So I know that FCAB is working on it, and I actually happen to know that the National Security Council and the National Economic Council at the staff level are currently taking a good deep look at supply chain issues. And by the way, I agree on the recycling piece, because for the future, that enables us to have material here in the United States that we can, support our batteries if we are under some kind of industrial stress due to conflict. On the industrial base, I'm worried about it, because the amount of growth that we're going to see across the entire market in this space is going to be huge, and DoD represents 0.1% of the problem. It's a really tiny piece of the big battery problem that the country faces. And so from my perspective, if we go more to an EV world and our peer competitors own the entire supply chain for the EV, then we could look like a 1973 fuel crisis, but we would look at it in terms of advanced battery capabilities. And so I'm super concerned about the industrial base and making sure that the US industrial base is supported and that we as a defense industry are supporting their effectiveness as well. So finding ways to conform with industry standards to the best ways possible and find ways to enable industry to sell to us more easily and more quickly and more effectively. And I think that we should support recycling, in the continental United States so that we have the capability of, maintaining local supplies if we have a problem with conflict.
Right. But there are areas that DoD has more agency over than others. So I think it would be interesting to look at some of those areas, right? There are big federal national level issues like permitting for recycling plants that DoD is not going to have direct control over. It could exert pressure. But in terms of some DoD potential, not fixes, but the ability to make progress, where do you see some of those? Kyle, I see you, Jim and Kyle.
So there's some manufacturing industrial based policy, of course. The Defense Production Act allows for the Defense Department to support industry, and we do in a number of areas, and we think that's really important. But I will tell you that it is my opinion that the reason we're so close with the Department of Energy on this and with the Federal Consortium on Advanced Batteries is that we think that DOE should lead in this space, right? We want them to enable us, and we want them to enable all of industry. So we can do things like we can try to get our standards right. We can try to share our safety standards with industry and bring them in as partners in the safety process. And we can support defense production capability. We can do all those things, but in the end, we need our DOE partners to help us get to the right answer for things that support the EV market and other big markets that are really going to drive US capability.
Do others have a comment on that? Do you agree?
Yeah, I would generally agree with everything there, Jim. I mean, we have an area to play in. DOE has an area to play in. They can influence this area. New administration, we'll see where they go with their loan programs and other things that DOE can really put some big dollars at. But battery recycling is a big area that I would imagine they're looking at for potential investment there. I agree the Defense Production Act, Title III type authorities underneath there, is meant to look at how to grow industry or capabilities there, look at capital investments that have national security impacts. So you can look at programs like that can do investments from a defense perspective there and can help grow this. But I think our goals here are aligned with industry. I mean, industry, most of these companies that are in the EV market or in some of these battery marketplaces are selling to their stockholders that they are about a green future, that they are about ESG type investing issues. So it's it does impact their bottom line where they can speak how they're cleaning up their supply chain. Apple's a good example of that, where they have taken a lot of effort to demonstrate how they've greened their supply chain. And so I think with the big EV market and the big battery players out there, they want to demonstrate that they can recycle their batteries and create options there. So when DIU helps in this space, right? We hope those conversations happen when we can align the interests of industry and the interests of national security and government. And so we've been reaching out to industry and talking to them about what they're doing from a battery recycling perspective. It's the quality of the materials post recycling that is the big technical side of things that we need to see improvement on. But I think our interests are aligned in end state. I mean, the ESG goals from industry have the same end state as the national security goals about protecting our supply chain that helps DoD. So I think there's hope there for movement in this space.
How many recycling plants do we have in the United States today, sort of ones that can do this at scale? Does anyone know? I don't know actually that number. But partly I'm asking that because what would it take to get to where we're even beginning to near what China has, right? So some of these, what are the obstacles to actually building recycling plants in the next 5 years?
I've seen we've met with at least 3 companies that are investing in this space. Nina, I don't know if we actually know the number of plants in that, but we've definitely met with at least a few companies that have invested. and heard from a number of large VCs that are putting dollars in this space. Our conversations have more been around what they're producing. Again, is it actually meeting the quality standards that would actually be of interest to DoD, right? If they're making subpar quality materials post recycling that we can't use, then that doesn't move it forward for us yet.
Right.
So
Oh, sorry, go ahead, Nina.
what Ben just said is that, yes, there are companies that are investing in this. In my understanding, and Jim and Kyle, you might have more insight into this, a lot of it, and you hinted on this, Nadia, is that there is this permitting issue.
Right.
And the permitting issue goes all the way back to the mining and the processing and the production. And there are states like California will never allow that again. There are rare earth mines that will never open again. There are states like Idaho, like Nevada, that have more experience, and there are radionuclides that are produced when you recycle and you process. And so they have experience with this. And so it's really, in some ways, becomes a political issue as much as a cost benefit industry issue. And I think we're going to see it play out in states that understand how to handle these byproducts. Kyle or Jim, do you have any insight into this?
So I admit I have no expertise in this space. I just know what I read.
It is a very political issue in terms of trade-offs, right? If you want to move toward renewables and toward EVs, you're going to have to make some trade-offs about what you're willing to produce here or not. Otherwise, we increase our vulnerability on China. Essentially, we become China has more leverage over us if they control the entire battery supply chain, which they do. So it is political. People are going to have to make choices about, having battery manufacturing facilities, in their backyard, and
Right.
recycling facilities, which are also, not all clean either. So that is a problem. But jumping ahead, so some have argued, well, we're just not going to catch up with China in our ability to produce batteries at scale and at cost that's affordable. What's ahead in terms of beyond lithium ion? Can we focus resources on that? And some of the Biden administration's plans to put more money into R&D in this domain is a significant portion going towards sort of the next generation in this space. Any thoughts on those areas? Maybe Kyle, because you're working on this in the Army Futures Command, with the Army Research Lab.
Sure. So I think this is one of the places that we all have a role to play. And I think this is another place where it's really important that we're engaging across the community and amongst the different agencies through venues like the FCAB. Some of the things that, that we're looking at and considering is, what is beyond lithium? And what is that going to mean from a supply chain, from the cost and environmental impacts with respect to the manufacturing, and ultimately what that's going to mean from a capability standpoint. And that I think this is where we do have an opportunity to put some emphasis behind it at the national level to really, project where we're going in the future and what those future needs are going to be, and target our industrial base towards some of those longer range objectives. That's my opinion. But certainly I think it's a space that is ripe with opportunity. And I'd also be very interested to hear what the others' thoughts on this space are.
Yeah, Nina and Ben, you're right in this area, right?
Right, I am, but I'm not a battery expert. I'm a combustion expert. So I understand how they explode.
Okay.
I understand how they burn, but I'm becoming more fluent in batteries.
So
what I kind of see from a high level point of view is you have a cathode and anode. Go ahead.
No, go.
Go ahead, Jim.
Go ahead, Nina.
You have a cathode and anode, and the lithium ion, you have a liquid electrolyte, and that is the danger. Even if you go to a lithium sulfur battery, you still have a liquid electrolyte. In my kind of very high level understanding is if you go to a solid state battery, you take some of the danger of fire away, because now you have a solid electrolyte. And I am still trying to come up to speed on what industry is doing. I know Toyota, some of the car manufacturers have done a lot of work. I'm sure there's a lot out there. But that would be my thought on where we go. You can get more energy density going to things like lithium sulfur, and they're looking at things like that for space. But you're not going to get away from the fire danger of lithium ion and the kind of capped energy density, certainly better than what we have now in lead acid batteries, but you're going to be able to go to higher energy density and more safety. Jim, do you know anything about this?
So yeah, so solid state electrolyte is a way forward potentially, but sometimes, and in most cases that we've seen, it starts limiting, the power density of the storage asset. There are other different storage technologies that we look at, but I will tell you that we go to a system of systems perspective on this. So the truth here is that I've got to be able to integrate lithium battery technology with flywheel technology and other energy storage technologies. And flywheel is kinetic energy storage, that I'm going at this from a whole systems approach, right? So the truth here is that we can talk about getting beyond lithium, except that there aren't but so many elements on the periodic table, and lithium's a pretty good one. And so, from my perspective, I think lithium batteries are going to be around here quite a long time, and we'll do stuff in, nickel cadmium and lithium sulfur and solid state electrolyte, but we're also going to be including other kinds of energy storage in this space. And this includes things like we should be taking a good look at superconducting electromagnetic storage, because that allows us to put a huge amount of power in a small amount of space. We're looking at flywheels inside the Navy pretty aggressively, not only to support Navy ships, but also to support installations and grid level storage things. I mean, you could support an airfield certainly with, some kind of flywheel storage technology. The other point that I would make here is that in the near term, we ought to be considering the benefits of hydrogen, right? So hydrogen provides some good enabling capability. You can increase efficiency in propulsion with hydrogenated propulsion. You can use hydrogen fuel cells and keep the weight of fuel out of airplanes. And I realize that fuel in itself is more dense than hydrogen in terms of energy, but when you're not picking up the liquid fuel, the density of hydrogen starts paying off really quickly. And so there are a lot of different technologies, and frankly, to I think Kyle and to Nina's points here, we need to reimagine this and re-engineer it. And frankly, part of this is getting beyond the battery or integrating batteries in such a way that the total power system performs at a high level, right? And so I don't know what's next beyond lithium ion, but I do know that better engineering has got to be part of it.
Well, Ben, yeah, I wanted to give you, Ben, the last word on the future, and then we'll wrap.
It's always hard to predict. You're always dangerous trying to predict the future. I just wanted to make sure, so DIU does have a project with a lithium sulfur battery, but it is for a space solution. I can't name the company just because they're not public yet. But so we are looking at other chemistries. We're, as Nina mentioned, we're heavily looking at, and we're talking to a lot of VCs and watching some companies pop out in the solid state arena. I do think there's some good solutions there, but those are solving more of the safety type concerns, less of the supply chain necessarily piece of this. From what we've heard from VCs and some other experts in the community is lithium ion is here to stay. We do need to accept that. There's different ways of making those chemistries and designing the batteries and separators and other things that are being looked at right now. And those have impacts on, on the, types of batteries. I mentioned before, the right battery for the right mission. It may be lithium ion, but different types of lithium ions for long endurance versus fast recharging, et cetera, and how they're designed. And this gets back to kind of the standards versus standardization issue, right? Standards on safety, as Jim was hitting on before, working with industry, trying to make sure we're engaged with them to get closer to them. But standards across and standardization across the different batteries being produced is a challenge. One thing DIU is looking at and engaging on with industrial-based policy and other elements of DoD is on kind of what's happening in the market with regard to new players. The battery space is a great opportunity for DoD and DOE to work together on looking at things coming out of universities. There's a lot of work at universities that don't always scale up. Why don't they scale up? Because industry already has a good, solid, cheap solution that they've got. And why take on another chemistry? Because they're not as concerned about maybe the supply chain issues that we're concerned about, right? You know, as much as I would love for the ESG end state to align with the national security end state with regard to clean as it relates to national security, they don't always align, right? And so, you know, sometimes industry won't drive that. So helping identify good technologies that transition faster, better out of universities and national labs, helping small companies show where there's some value and help them scale a little bit because their chemistries may help with some of the national security supply chain issues that DoD is concerned about, and bringing them to the forefront can help urge the market forward and make some movements there. Scale will always be the problem, or is DoD going to buy enough batteries and be able to make the market move there? But you know, DIU has proved time and time again that you know, we can help companies have a small business with the DoD to help them grow with a much larger portion of their business with the traditional commercial sector. So we're having those conversations and trying to make some movements there, but it's really hard to predict which chemistry is really going to lead out. And again, I think lithium ion is here in the long term, right, as the battery of choice.
Well, it's helpful to hear all of your views on that. So as we try to wrap, I'll highlight a couple of the points that we made, or a number of them. Just that from my perspective, the operational concepts using batteries are here to stay, that batteries can solve some real operational or make progress on real operational challenges for the US military. Second, we talked about hybrid and the different sort of hybrid is also here to stay, whether or not you retrofit or design for the future. Those are some issues to look at and some of what we discussed. Third, there seem to be opportunities for improved communications between the commercial sector and DoD on issues such as standards, as well as the services, but that does seem to be an area of opportunity. We talked about recharging as well, thinking about that in parallel. It's obviously essential. Nina brought up many key points related to that. And then supply chain issues at the end. Obviously, we didn't solve that problem. we can't solve the problem, but it is a key limiting factor down the line on DoD's ability to depend on these future technologies. We need to be able to supply them to a certain degree ourselves, or at least with allies and partners. So I want to thank all of you. I know you're all really busy.
Nadia, can you bring up one other thing that I think we talked about that I kind of see as really unifying here, and that's the issue of the policy of the politics of permitting.
Right, that's a key issue, and it's one that's in our control, right? There's a lot externally that we don't control, but the permitting and making it easier to produce the facility, to build the facilities we need here, it is a political issue and it can be solved. Completely agree. So thanks to all of you for your service, also to our country. All of you are working in this nonprofit government sector, doing great things, and I really appreciate you taking the time to inform Hudson and its listeners on a really important subject. Thank you.
Thanks so much.